This is the final set of notes for the atmosphere and weather unit. In fact, this is the final set of notes for the year. It's called ES 11.5 Weather Maps. You can see here in this weather map that a lot of information is provided, and it helps if you know how to read it. Weather maps are used to show current weather conditions, including temperature, precipitation, fronts, and severe weather. Accurate weather maps are only possible with sophisticated instrumentation and instantaneous communication between weather stations. Our ability to forecast weather is also enhanced because of satellite technology. Each one of these little dots here is a weather station, and the map representation here of the weather stations is called a station model. Station models are a shorthand way of showing a wide array of weather data in a small area on a weather map. Station models show temperature, dew point, wind speed, wind direction, cloud cover, and atmospheric pressure, and precipitation if there is any. So this is the key to reading it. The sky cloud covers in the middle. Wind direction is the tail with the feathers on it. Temperature is top left, dew point bottom left. If there's precipitation, that's those two dots right there. Atmospheric pressure is in the top right, but you have to decode it. And then sometimes there's a pressure trend. This pressure trend would be it just went down by 3. And here's another US map showing a bunch of weather stations and the weather at those stations. So if the circle is filled in, it's cloudy at that weather station. This station on the right here is half filled in, so that's partly cloudy. Wind direction is shown by the cardinal direction of the tail, and wind speed is the number of barbs or feathers on the tail. This station here would be a northwest wind, meaning the wind is blowing from the northwest, and the wind would be blowing at 20 knots. So each longer tail feather barb thingy is 10 knots. If there's a short one, it's 5 knots. Temperature is on the top left in degrees. Dew point is on the bottom left. The closer the two numbers are together, the higher the humidity. If the numbers are the same, the humidity is 100%, because the dew point is the temperature at which humidity would be 100%. The hotter the temperature is, the more moisture the air can hold. So if the temperature and dew point are the same, humidity is 100%. There's different symbols for different precipitation. You don't have to memorize all of these. Just know that a couple of dots means it's raining, and if it's asterisks, it's snowing. The thunderstorms symbol's kind of good to remember too, but I think if you have to read one of these things, you'll almost always have a key. Atmospheric pressure at the top right in millibars. There are always 3 digits given, but it has to be decoded. The last place number is always a decimal, so that's 0.9 in this example. If your number is less than 500, put a 10 in front of it. If your number is above 500, put a 9 in front. The atmospheric pressure in this example is 1012.9 millibars. And in this example, the pressure would be 1013.8. All atmospheric pressure in millibars is going to be between 950 and 1050. All right, another thing you'll see on weather maps sometimes is isolines. These are similar to the lines on the topographic map, but they'll be showing either pressure or temperature. They connect points of equal data. Isotherms are connecting points of equal temperature, or in this example, we've got isobars that are connecting points of equal pressure. We have a low pressure center, and moving outwards from the low, the pressure is getting higher. The L means low pressure center. If it's an H, it's a high pressure center. Why is there no H on this map? Well, the answer is that there is an H somewhere, it's just not in this vicinity. It's probably somewhere else in the United States. So air always circles clockwise around a high pressure center and counterclockwise around a low pressure center. And at a low pressure center, air is also rising. At a high pressure center, air is also sinking. And this is due to the Coriolis effect. High pressure is associated with clear skies, and low pressure is associated with clouds and rain. So for the L's, I think lousy weather. For the highs, I think, hey, how you doing? Let's go outside. It's not raining. So clouds and rain at the L's, clear skies at the H's. So in this map here, you'd expect to find rain in the south and southwest, and clear skies in the northern part of the country and Canada. And here's a closer look at that diagram. Low pressure center, air is rising, cycling counterclockwise. At a high pressure center, air is sinking, cycling clockwise. And remember that air always flows, or wind always blows, from high to low pressure. So this map is an oversimplification, but it asks you what direction is the wind blowing in Plainsboro. So if it's blowing from the high to the low, in Plainsboro it would be blowing from the west. So it would be a west wind. It would be flowing west to east. Over the next 2 days, for a few days, what kind of weather would you expect in Surfsburg? Well, generally speaking, all weather in the United States moves from west to east, so that low pressure center would be coming on top of Surfsburg in the coming days, and so they could expect some clouds and rain. Fronts. So there's different symbols on the map that represent air masses. And when an air mass changes, it's either a warm front, a cold front, an occluded front, or a stationary front. And the symbols are always pointed in the direction the front is moving. And a stationary front's not moving, hence the name. A front is a boundary of two air masses of different temperatures. The temperature difference means there is also a density difference. The warmer air mass rises above the cooler air mass. Fronts cycle counterclockwise around low pressure centers. A cold front happens when a cold air mass is overtaking a warm air mass. The warm air rises at the front boundary. It produces cumulonimbus clouds and thunderstorms. When a cold front passes, cold air is coming into the area, so temperature goes down and the air pressure increases. At a warm front, you have a warm air mass overtaking a cold air mass. The warm air rises ahead of the front boundary, producing stratus clouds and light precipitation. Before the warm front arrives, you get those stratus clouds and the light rain. When a warm front passes, warm air is coming into the area, so the temperature should go up and the air pressure decreases because warm air tends to rise. So here's a closer look at that diagram. This is a side view of the front. A stationary front is a boundary of a warm and cold air mass with no movement in either direction. There is usually precipitation at a stationary front, and the rain stays in one place for days. So rain for days is what I think of when I see a stationary front. An occluded front is a complex boundary where two cold fronts interact. It's also associated with precipitation. And so on this map, you can see cold fronts, warm fronts, occluded fronts, and stationary fronts all on the same map. Notice that they're all cycling around the low pressure centers. The high pressure centers do not have fronts. So weather generally moves from west to east in the United States, and wind always blows from high to low pressure. Fronts move in the directions the symbols point, and fronts circle counterclockwise around a low pressure system. Air cycles clockwise around a high pressure system. Those are weather map rules. Satellites and weather. The first weather satellite was launched in 1960. Satellites used sophisticated imaging techniques to give us a visual image of weather. Doppler radar can show us where precipitation is moving. And it can show us where a hurricane is as well. Before the invention of satellites, people used telegraphs to communicate across long distances about lots of things, including weather. This is before even the telephone. They would use Morse code. The weather happening in one place was an important clue about what was coming. So, why do you think it was easier to predict the weather without satellites on the East Coast than on the West Coast? Something to ponder. And that's it for the notes. Here's what it looks like all typed up on one slide. Of course, you can use the fill in the blanks or handwrite it if that suits you. Thank you. Goodbye.